Okay, think it's up. It has been a long time, so yeah, it's been a few weeks since I've been on here. I've been just busy doing various things, had some trips and stuff. Also got COVID, that was fun. But I'm back working on Astral Horizon. I've actually been working on it in the meantime, so I'm not right back where I left off. But I believe where I did leave off with the last stream was working on my new navigation system. So, yeah, that is pretty much working in the game now, which is pretty exciting, at least the most basic version of it. I can, let's just demo it in here actually. So, I haven't updated the scene with the new navigation system, so this is a good time to do that. We have this nav grid object, that was the old navigation system. So I'm just going to remove that nav grid volume and add a nav volume. That's the new navigation system. And we're going to need to edit this volume and make it encapsulate the whole thing. Make it smaller on the edges, I guess. Then let's see, blocking layers. We need to set that to default, and we need walkable and nav blocker. Static only is true. We'll keep that at 1. Keep that at point. Oh, that can't be. 0.1 is way too small a value for this. We'll do 0.5. Cool. Let's go ahead and bake that. Should be quite fast because this is a very simple area. It's actually taking a bit of time, interestingly. Alright, that is the nav volume, and it looks really complex, but it's really not too bad. It's just a bunch of different, mostly rectangular, but they can be other shapes too, regions. See here some ones with angled surfaces, and the characters can use those for navigation. Oh, just heard someone scream outside. That's always a good sign. Hopefully everything's okay. So now, let's take this guy, and he should already be set up to be using that nav volume, because I already modified the prefabs and sort of got this working in my main scene. But I want to just give him a patrol path that will take him into the air. And we'll put this back down on the surface. Okay. Let's make sure we autofocus the scene view when we run, and we do what? How does... Okay, I think these things are weird. They should be the opposite of what they are now. Anyway. This should make it stay in the scene view rather than going to the game view when I run. And we can just watch what that guy does. Oh, did it not work? Okay, it did work. Yep. So that is working. Cool. Oh, I think one of them was probably set. Oh, shit. Well, I gave him a path that makes him automatically see my player, so I'm going to have to change that because the player should not be involved in this test at all. Let's just pull up the player over here. There, he should never see me. What's he doing now? That's interesting. Should be on the nav mesh. Oh, it's because, right, it's this door. That door is ignored by the nav mesh because it is not static. And in real scenarios, this shouldn't happen, so I'm just gonna get rid of that for now. We don't need that. And then probably want to rebake the nav volume. Do I have 2 nav meshes? I think I do. Oh, I have 2 nav grids too. When did I make that? Whatever, we'll just keep this one. Be nice if I could optimize some of this more. It still takes a little bit longer than I'd like in any real scenario, which is interesting because it was super fast in my test project. But so far I haven't found any place to make any obvious performance gains. So I'm going to keep it how it is for now and come back to that later. Generally, I've been going with just using smaller volumes and linking them up with external connections, because that way the baking for each individual volume is pretty fast. So, yep, the volume is rebaked. So this is interesting. He's not landing ever. Did I mess up my nav mesh by deleting that nav mesh surface? Ah, yep. This one wasn't baked. That should fix it. Man, it is quite hot. I would like to turn the fan on, but I don't want to mess up the audio of the stream. So I'm going to suffer the heat. Okay, so seems like everything's working now. So what I want to do, and what I've been working on most recently, is, let's see, when he starts flying here, this path that he takes here is not supernatural. It's kind of just straight line, straight line, straight line, and that doesn't look great. What I really want him to do is take a more curved path. And to do that, I'm going to use a spline. Now, to follow a spline, my current plan is that this guy is just going to simply stop using physics for his movement and just move manually on the spline using like rigid body move position. I don't know how well that's going to work, but I want to give it a try. I think it should give me the possibility to make much more natural movement for these guys and make them feel like, you know, they're not just AIs moving along jagged paths. And I'm hoping it doesn't mess up performance too much as well. So, what I have right now is this nav agent script. And I think what I want to do is extend that nav agent to do what I want it to do. And then I'll probably have to add some flexibility in nav agent itself. But in the subclass, that is going to be game specific because it's going to do a bunch of game specific stuff. So we'll just put this in scripts characters, I think. Create spline nav agent. And I already got Rider open, so that should be quick. There we go. Get rid of all that crap. And we're going to make this extend nav agent in the InfoHazard HyperNav package. Cool. So let's go in here. And the first thing I want to do is add behavior as soon as it gets a new path. So this is going to be in path ready. Let's go ahead and make this protected virtual. Then I will just override path ready, and we'll do base.path ready. And we now want to check, after we've called base.pathReady, if current path is not equal to null, then we have a new path. So if I'm actually going to invert that condition and just say if current path is null, then we return because there's nothing else to do. Now, we need to save a spline path. And spline path is just a pretty simple spline class that I created on my own. It doesn't really do anything special right now, and this could just be a generic spline implementation, but I have a feeling I'm going to be adding some path-specific functionality here in the future, so I just called it spline path. Now, we need to say spline path equals new spline path. Current path. Let's add a serialized field for the tangent scale. Oops. And another serialized field for the sample count. Samples per segment, and we're going to initialize that as 5 by default. So for the tangent scale, we'll just pass a tangent scale. For samples per segment, or sample count, it's going to be samples per segment times spline path dot point count. And ideally we would want to do subtract 1 from that because that's how many segments it's going to have. Alright, so there's our spline path. Let's start by just drawing that so we can see that it's working. So I'm going to just do an onDraw gizmos. This thing already has an onDraw gizmos, so I'm just going to have to make that virtual. Probably just make everything in here protected virtual while I'm at it. Let's see this. All right, we can leave those as is for now. So we have our spline path. Now we need to override on draw gizmos. If debug path, we need to put an accessor for that, I think. Debug path. Protected bool debug path. Yeah. Might as well make this public, actually. Now, we want a private int debug samples equals, let's give it 50. Less than debug samples. First, we need to store the last position. Then at the end of this loop, we're going to say, well, or at the beginning, I guess, we're going to say vector3 cur position equals spline path dot get position. Then if you're familiar with splines, you'll be familiar with the fact that passing a parameter directly into the spline function is not going to give us uniform distances between points. So we have to convert it using this get parameter function. So I'm going to say spline path dot get parameter. Then that's going to be I divided by float. What are we going to call this? I malt equals. This is going to be debug, not debug samples. Oh no, it is debug samples. -1. That's the total number of points we're drawing. Then, is it -1? Yes, it is, should be -1. Then we also need to we're gonna multiply this. Multiply it by the length of the spline in distance units. Dot length. This is how physically long the spline is, because the thing we pass into get parameter is a physical distance along the spline in the range 0 to the spline's length. So then I malt. Then at the end of the loop, we'll say last position equals cur position. Now, if I is greater than 0, meaning we've already gotten the first point, so we already have the last position, then we can say gizmos.draw a line from last position to cur position. Right, now we just need to set the color. Let's draw this thing green, I guess. Do it up here. Color equals gizmos.color. Gizmos.color equals green. I don't know how important it is that you restore the color when you're done with the gizmos, but I know for some things in Unity it's very important, or you can make the whole editor look weird. Alright, so gizmos. Yep, this should work. Oh, no, there was one thing I missed, which is if spline path is null, we don't want to do this. Actually, we want to say Let me organize this a little bit too, because if we don't have a current path, then it's null. And then also we want to override the stop and say spline path is null. All right, let's see how this looks. Oh, you know, it's not going to do anything because I haven't actually put the component on him. So let's add the spline nav agent. Copy the params from this, although I don't think those are going to end up being used soon. Tangent scale, that should not be 0 by default. I think 0.5 works pretty well, so I'm going to put that as the default. Then everything else should be good. Just going to take that off. Okay. Now, I don't think anything was referencing that nav agent directly. I think that they're just doing get component, and this will, since it's a subclass, the get component will still work. All right, so we're getting a null reference exception. Getting a bunch of null reference exceptions. Let's see, what went wrong here? What? Oh, this is, yeah, that is not the right thing to pass there. This is current path dot waypoints dot count. Surprised that worked as well as it did, honestly. Feel like that should have messed other stuff up. Yep, see, there's our spline. That is looking pretty good. And then obviously when he just has a straight shot, the spline is not going to do anything. So maybe I want to have a special case when there's only 2 points, but I think that should be a pretty rare case and probably not worth handling right now. Yeah. So the next thing I think is, you know, obviously having him follow this spline. And like I said earlier, I want to do that not using physical forces. I think just having him directly move along the spline. Physical forces could be an option too. Like I could project his position along the spline and try to move aligned with the spline. Would that be better? It'd certainly be more realistic. Maybe I should try that first. Although, so projecting the guy's position on the spline is not going to be the easiest thing to do. I mean, it's easy enough to code, but it might be a little bit expensive. Maybe not too bad. Let's give it a shot. So, in the Spline Path class, I'm going to add a new function that's going to be project. Let's see. Let's put it here. Public float. I'm in caps lock. Float project position. Vector3 position. Then we're probably going to want some kind of iteration count because I don't believe this can be done analytically. Maybe it can be done analytically. I feel like that's a huge amount of math. It might end up being just more complicated than it's worth, though. So we're going to probably just do it numerically. Let's see. Did I already have a way to do this in my old Spline class? Because maybe I can just steal that. I stole most of the Spline code from an old Spline class that I wrote for doing spline meshes, which itself is based off of the Cinemachine spline. Let's see, this is packages. Yeah, here's my old one. So is there's no, nah, it doesn't look like I had a way to do that. Okay, so I'm gonna have to write it. Let's just pass in an iteration count for now. And let's say 5 iterations. I have no idea if that's the right number at all, but we'll use that for now. All right, then we also probably need... The first thing we need to do is go down this spline linearly to sample, to find which point is closest, because we don't want to start with a random point on the spline or we'll fall into a local minimum. So at least once per segment, I need to do a sample. Can I get away with only doing it once per segment? Is it possible that a single segment can have a local minimum of distance from the target point? I think it is because there's the end points of the segment. Although, so if I just do it at every point, every vertex of the spline, I think I should be good. If I do it every vertex of the spline, and then take the local, or let's just draw this out. So, let's see, I have a spline, looks something like this. Here's a vertex. Is that? No. Obviously, this is going to be a vertex. This is a vertex. This is a vertex. This is a vertex. This is a vertex, and this is a vertex. That seems fairly reasonable. So then if I have a point here, let's give it something a little bit tricky. Here. So if I sample this point, then it's going to converge towards this spot here. If I sample this point, it is probably going to go to that one. If I sample this point, it's probably going to go somewhere around here. Oops. I'm doing hollow circles for those. I feel like I can't just take the starting point that's closest to it, though. No matter what I do here, this isn't going to be super exact. Let's see, maybe there is an analytical solution. Let me try figuring that out, just as another option. So let's define a function called just D, I guess, capital D. No, that's going to be confusing because we're going to do derivatives. Just call it cost, C. C, and we're going to be looking at a single segment. So from from 0 to 1, C of t equals then let's say we have a spline function, S of t equals spline function. And so C of t is the distance from the target point to the to S of t. So that is going to be the square root of S of t minus P. I'm going to call this point that we're looking for P. Now, of course, these all have an x component, a y component, and a z component. So if we expand this, this is Sx of t minus px plus, let's put these in parentheses, sy of t minus py plus sz of t, what did I just do? Minus pz. All right. Now, I need to expand those to actually include the proper S functions. So what do those look like? You know, actually, I think I'm going to move this over to Desmos rather than Notepad. That should hopefully be a little bit better. Let's add our functions in here. So, oops. So first thing, we need to define S of t equals, we'll just call that 1 for now. I'm going to put in the actual spline function later. Then we need px I need we're going to have to do p1, p2, and p3, not x, y, and z. That's fine. P1 equals 4, P2 equals 3, P3 equals -1. Actually, to start off, just do it with only a single component. We only have x values, so S1 of t equals 1. Now, c of t equals square root of, I don't think it likes the square root. I think, yeah, we needed that. And don't need those parentheses. S1 of t minus P1. Then we don't need that for now. All right, now let's get in the actual spline function. Let me save this as spline minimum. Then need to open spline curvature. And can I copy a bunch of these at once? I want to just copy a bunch of things at once. Okay, I guess probably can't. Whatever, we're just going to go back to spline minimum. And also, we're going to change this from P to something else. Because I'm using P elsewhere, we'll just call it V. So, now we need to define our spline function. So, the spline is defined by 2 points. So, P1 equals 3, P2 equals 6, and also 2 tangents, T1 equals 3, T2 equals 7. Let's try a negative value, -1. All right. Now we need the spline function. I'm actually going to just go back here and have both of these open at the same time. Spline curvature. So this is our spline function. And now I can mess with the tangents and the points. And then let's get rid of this. Well, let's put this down here. So now cost of t equals f of t. Let's call this x. No, x is not proper here. So now this function will graph the distance from t to v1, right? Square root of... This needs to be squared, doesn't it? Oh, okay, so in this case it's not actually... That square doesn't do anything because it's only one component. But for the single component case, this seems correct. Let's see, where... We're looking just where our x is closest to 4, or where our value is closest to 4. Right? So where it's closest to 4 is going to, of course, be where it is 4. Okay, so this isn't very helpful. Let's go on to a two-component thing. Because two-component should be easy to pull into three components. So I'll say v2 equals -2. Now I need another spline function that's going to be the y-coordinate. So actually I'm going to change this guy into f1 of x. And now we need these p's and t's are going to need to be duplicated as well. Could I just do p11, p2, 1, t11, t21. Okay. Now we need... give me 1 second. Alright, all good. So let's see, P12 equals 6. P22 equals -1. T12 equals 3. T22 equals 9. Something large. Alright. Then we need to copy the spline function again and make that f2 of x. Change all of these to the 2 value. Alright, so there's our second spline. I can also play with that. just move it there so it's not in the way of us. So now we're finding the place where the total distance between the values of these splines and the point for -2 is the lowest. So there's the first component, and we're going to add f2 of t minus v2 squared. So now we have our local minimum, which is here. So what it looks like is that this function, or this function, is a cubic. So if this is a cubic, it should be easy-ish to solve. I already have code that will solve a cubic, so I don't need to worry about that part of it. The challenge is just going to be reducing this to the simplest form of this cubic. Then I can just plug it into my solver. Then, oh, okay, so actually, no, so I don't want to solve that cubic, because solving it would be basically finding the intercepts, which this doesn't have any. What I want to do is find the local minima, and then evaluate them to find the global minimum. Okay, so yeah, we definitely are going to need to unwrap this, which is going to be very yucky looking, but let's go ahead and do it. So here's part 1 of the spline function. You know what, I'm actually going to make this a little bit nicer. I'm going to say C11 equals P11 plus T11, and C12 equals, or C21 equals P21 plus T21, C12 equals P12 plus T12, C22 equals P22 plus T22. That will allow us to simplify this a little bit, and all of these guys are constants, so that's not going to affect our derivative at all. So, however, I can't do anything with 1 minus x because we need that expanded for the derivative. So this I'm just going to call, I'm going to get rid of this guy and just say, what was that? This is C12, C12, then this is C22, that should be before the x. Alright, that simplifies that a little bit. Oh, and this, I messed something up here. Nope, that was, never mind. And this one, this is C11. This is C21. I really bet nobody was expecting a math stream. Calculus. It's everybody's favorite part of game development. I think it's fun. Alright, so there's those. Let's pull these guys to the bottom because these are what we actually care about. And going to start unwrapping this. So we'll make C1 of t, which is I think I messed something up. Right. The control point should be minus. The second control point is supposed to be minus. There. That gets us back to where we were before. Alright. So then this top one is what we're looking at. And, the top one is suspiciously matching the bottom one. Is that because this one's... Oh, okay. So, what I've just learned is that this is not a cubic. So that'll be interesting. I'm not convinced that I have everything right, though. No, I think I do. Okay. Let's unwrap this. So, f1 of t. Let's make these in terms of t. Oops. Is this. This. F2 of t, we're not going to deal with right now. We're just going to leave that alone and solve this first part. So, okay, this is going to be a huge amount of work to unwrap. And we're going to get terms that are up to order 6. Okay, so I'm starting to realize that this may be completely unfeasible. Because we're going to have terms that are like t to the sixth in here. And I don't think I'm going to be able to get rid of the square root either. So I don't know how possible it is going to be to analytically compute a solution to this. Okay, so I might have just wasted a bunch of time, but I did some fun math. I think what we're going to do instead is we're going to use, what do you call it? It's like Euler's method or something. The one where you just sample a point and you see which way points more towards the destination and just go that way. And if both ways point away from the destination, then you have found a local minimum. And I just need to sample enough points that I don't find all of the, that I try to find a global minimum. So looking back at my shitty MS Paint, it seems like we actually need to. Somebody just said something in chat. It's a walk past. Huh. Okay. If you're walking past the stream because I'm talking about math, I totally understand that. Usually I do more stuff in the game engine with coding, and I am going to get back to that in a few minutes. But just got to figure this out. Okay, so I think for every segment, I probably need to compute the local minimum. All right. So let's see. We'll do a private float project position vector 3 position and iterations. Don't need the default here, and then we also need a segment index. Or not segment, it's going to be a point. Actually, might as well just put that as float. Start parameter. Okay. Now we're going to say for some iterations. Oh, and also, there's one more value we need, which is a alpha, I think, which we can simply make. We're going to have to decrease the alpha each time, I believe. Let's try starting the alpha at the length of the segment. So float alpha equals 1.0f over point count minus 1. Then after every iteration, we're just gonna have the alpha. So we need to sample the position. Sample equals get position. Let's add float parameter equals start parameter. We'll get the position at the parameter. We also need the tangent. Now we want to move the position. Oh, we need to see which direction to go in. So if the tangent is pointing towards the position, we go in that direction. Otherwise, we go in the opposite direction. And we can check that with a dot product. If vector3 dot position minus sample and tangent is less than 0, tangent times equals -1. Then we need to normalize the tangent. Or what if we just multiply the tangent by that dot product? Times equals. Let's try this. Let's multiply this tangent by the dot product. I think we need to normalize it first, though. Or maybe not. No, let's not normalize it. So I guess, yeah, the Euler's method is you add the derivative onto the input value, right? So we would basically be saying here parameter plus equals. Probably don't need to decrease alpha like this anymore. Then the alpha can be constant. And probably want to make this 0.5. Then we will return the parameter. And then we also want... No, I guess that's fine. So now here we will do just a point count. Float param equals I over point count minus 1.0. Get float pause equals project position, position iterations, param. We need to calculate the point, so nearest equals sample, or get position, pause. Then we need to find the minimum of that. So float min dist square equals float dot constant infinity, and float min param equals 0. And at the end of this, we will be returning min param. Right, so we get the nearest. We need to get square dist equals square magnitude of nearest minus position. I never figured out if we needed to normalize that. But I think we do. Square distance, then if square distance is less, let's do if square distance is greater than or equal to min just square, continue, just square equals min distant, no, min param equals param. Okay. Now, to test all of this, we're going to add it to onDraw gizmos. Let's set the color to yellow and equals spline path dot project position. Keep the default iterations. Then we will draw a line from transform.position to spline path dot get position nearest param. Now I feel like this is gonna be too inefficient for me to actually use it. I'm gonna have to significantly reduce some stuff. It also doesn't seem to work at all. That's fun. Alright, let's let him do it again and then slow down time. So, yeah, that's not correct at all. It's always snapping to a point, to one of the spline's vertices, rather than the nearest point. Now, is it actually snapping to the nearest spline vertex? Because then that would tell me that at least the outer part of my function is working. It doesn't seem to be. If it was snapping to the nearest vertex, it should be here. In fact, it's possible that the inner part is working and the outer part is the problem, in which case that would be pretty easy to solve. Hopefully. So, spline path. So it's I over point count. We project the position using that parameter. We get the position on the spline. We get the square distance between that nearest point and the target position. If that square distance is greater than the one we've already found, which starts at positive infinity, we return, or we continue. Otherwise, we store that. That seems correct. Oh, that's why. Because I'm passing param here when I should be doing pause. Alright, so now it looks like it is working some of the time, maybe? Let's see. So clearly not all of the time, considering that's way up there. Now, what I want to probably do is draw all of the attempts it makes so I can see what's going wrong there. So I'm going to go into, where were we? Spline nav agent. I'm going to get rid of this. And we will do so we only want to look at the one that wins. I'm looking at the wrong class. We'll say int min segment 1 min segment equals I. Then I'm just going to put a param in here. This is going to be hacky, but it's fine. So the start is going to be sample, the target is going to be position, the color is going to be color.lerp from color.red to color.blue with the time of I over iterations minus 1.0. So then I just need, say, project position iterations min segment over point count minus 1.0 true. Oop. Not seeing any of those debug lines. We should be doing this. Oh, I know why. Because we still need to actually call that function. Alright, so I think they're just diverging too much. And that is because I need to do that. So we're still not doing great here. So we're using the alpha. So if this is a dot product between two normalized values, it must be less than or equal to 1. Oh, so I guess the tangent Well, no, that... Right, because the tangent... The dot product here should be fairly high. Then the dot product here should be fairly low. So I think it's going to go here. Then it's going back here, which doesn't make sense. Then it's going all the way to here, then it's going back here. So if the tangent points this way, which it does, the dot product is going to be negative. So we're going to be decreasing the parameter, which we are. We're just decreasing it by too much. Position minus sample dot normalized tangent, which is also normalized. Let's print out these dot products. this, we need to find one that's incorrect. Okay, yeah, here we go. What? It's, oh, because it's still drawing gizmos. Okay, whatever. It's going to be the same values. Or actually, why don't I just put it on clamps now? So, iteration 1, or iteration 0 is where we start. There it's 0.9. Iteration 1 is going to be here. Negative 0.92. Maybe what I need to do is try to calculate this distance in parameter. So what I could actually do is, so I can project the distance along the tangent. Basically, normalize the tangent. But not normalize the distance. Or maybe I just need a lower alpha value, honestly. What if I try the lower alpha value first? No, still doesn't work. All right, let's try. not using alpha. Let's do distance instead. So we're going to dot. We're not going to normalize this. Next, we're going to say float target distance equals let's keep track of the parameter distance. Distance parameter. Distance plus dot. Then parameter equals get parameter distance. Okay, so yeah, now it's looking pretty good. So that's then get rid of this and put back this. So this, yeah, this seems pretty reliable now. Except when it isn't. I think that's because the tangents are 0 along that line. All right. I'm gonna go to the bathroom. I will be right back. Right. I'm back. So the one problem we're having now is just that when the tangents on a path that is exactly 2 points are always 0. And I think the easiest answer to that is just to put in a special case. So let's see. Let's make this is less than 2. Else if dot length 2 return positions 1 minus positions 2. Oh, not 2. 0. That should solve that, I think. The bigger concern, now that this is working, is performance. Because if I have multiple characters moving on splines at the same time, I really can't have that be a significant performance drain. Because there's going to be a lot more stuff that's going to be causing performance hit, and something as trivial as this really shouldn't be hitting my performance much. Let's, I guess, go ahead and take a look at the profiler and just see, once we start doing that, how much time it's taking. Although actually, I don't think it's going to show up in the profiler. Think. Float. If we do that in update, then we should be able to see how much time we're spending in there. And since, let's do a profiler marker using, how does it work? New profiler marker, project position. Auto. Let's pause and just check out one of our frames here. Oh, shit. Alright, and we want to see timeline. Actually, I think we don't want to see timeline, we want to see hierarchy. This is player loop. Where is script run behavior update? This is... I guess I could search for it. Spline nav agent.update. So for one agent, we're using 0.1 milliseconds per frame. However, this is on a very good CPU, so I don't know how that's going to look on like an i3, which ideally I would like to be able to run this on, or at least like an i5. It's probably not the biggest concern right now, and I can probably optimize this later. Because, I mean, I think, maybe what I would be doing is, like, not doing it every frame. I guess this is a very short spline, though, so it could also cause issues on longer splines, because the time will scale linearly with the spline's length. Now, what if I optimize it a little bit? Let me see if this works. If I just see which point I'm closest to and work from there, rather than checking from every point. So let's see. We will get rid of that. That. So we do need the prim, and we need. Actually, we don't need that. We just need to say vector 3 point equals get. We can just do get position I, or positions I, to avoid a function call. Then we'll keep the square distance stuff. We don't need min param is just going to be, I'll just call this int best start equals -1. Best start equals I. Then we get rid of this. So param equals best start divided by point count -1. We do project position. We don't need that. Then we return pause, not param, pause. Now, I'm curious to see how reliable this will be on a more complex spline. Looks like not very, or I'm doing something wrong. So it seems to be doing fine on this first spline, but at one point it gets to the end. Okay, that's because the tangent at that end point is 0, and once it gets there, it can't go anywhere else. So I need some way to get the tangent at the endpoint. Yeah, so it's weird. Like, at these endpoints of the spline, technically the tangent is 0, even though obviously the curve goes somewhere. But if the tangent represents the derivative of xyz with respect to t, then that derivative is 0 at the endpoints. We could just not allow the endpoints to be start points for this. Although I feel like if it reaches them ever, it's stuck there, so that might still not work. Let's try it, I guess. So, yeah, so we'll say I equals 1, I is less than point count minus 1. That'll save a little performance too. Of course. Then we need a special case for the 2, or for the one that's too long, because there will be no points to evaluate there. But in that case, we actually can do something really easy. If point count equals 2, we just need to do a dot product, I think. I think this is as simple as dot position minus position 0 line over line dot square magnitude. Think that'll give us an exact analytic solution for when it's just two things long, and then not have to worry about that here. All right. Is it working? Seems to be working. I don't think it works along here. Okay, we need to convert it back to distance. Or we need to convert it from distance to parameter. So we'll actually do this over length, get rid of this, and do get parameter. Still not working. Oh, wait, maybe it is. Yeah, I think I was just looking at it from the wrong angle. Yeah, okay. That's actually correct. Ish. Interesting. It should be an exact answer, but I'm tempted to say that that's good enough. So early on, there was some issue going on. Yeah, okay. Because it was going over the end and couldn't get back to where he was. So seems like I haven't really solved the issue of the tangents. Maybe for the tangent function, I should just clamp the parameter. Then I could avoid any of these special cases. Less than 3, that's curvature 0. So yeah, what if we clamp the parameter equals mathf.clamp parameter 0.01, 0.99 f. I guess that clamp should depend on the number of segments. The more segments there are, the closer this should be to 0. It should really just be like 0.02 divided by the width of a segment. Float clamp end equals 0.02f over dot count minus 2 minus 1, and that's point count. Then we'll just put clamp end and 1.0f minus clamp end. That seems reasonable-ish. 0.02 to the end of a segment. I think that's fine to clamp the tangent in there. Alright, let's see. How is it working? Still good. Still good. This one's not. Oh, yes it is. And yeah, that's fine now. Now, what's it look like when he gets back to the very beginning of that other one? Still not great. I'm gonna stop recording the profiler. let's actually step into the code now, see what's going on here. So if we start here, we're going to go back to the position, or the very start, where we're just going to guess the tangent is about what it is right here. Let me just step through this. We want to go in here. So the start parameter is 0.33. Parameter distance is... That doesn't seem right. That doesn't seem right. What does samples look like? There's something up with this segment. What's point count? Point count is 4. Oh, okay. I know what the issue is. Maybe... we need to not include points in the spline that are too close together. Okay, so Let's figure this out. Let's do a static list. Static list vector 3 temp point new. It's read only. Then the first thing we do is temp points dot clear for pass dot waypoints dot length vector 3 v equals pass dot waypoints I dot position. Now if temp points dot count 0 or let's see, if greater than 0 and vector 3 dot square magnitude temp points dot count -1 v is less than 0.0001. 4 zeros. I just want 0.01 squared. 0.01 times 0.01. Nope, that's not what I wanted. 0.01 times 0.01. 3 zeros. Then we continue. It wants me to use the fancy index from end thing. You know what? I will go ahead and do that. No, I won't. This is the library. This should be compatible with earlier C# versions. Then we just say temp points dot add v. I can also just say vector 3 v left 3.0. Then just not do that. I'm going to invert this if, because v last equals v. If I is greater than 0, or vector c dot square magnitude is less than that. Oh, no. Oh, and you know, actually, we want to do this here. Because, oh, god damn it, we only want to set v last when we actually added something. Alright, so this will let us ignore points that are super close together. Let's see if that helps. it did not. Maybe my threshold's too low? Let's see. Let's go back into project and see what's happening again. Once again, it's 0.3. Okay, so I think I didn't, oh, you know what I didn't do, actually? Completely forgot to actually use these 10 points that I calculated. Let's try it now. I've been on for 2:15, it looks like. I'm not ready to stop yet, so I can go a decent amount. Okay, now it's working. Cool. I can go a decent amount longer, I think. And it looks like this thing is working now. So now, I think the next thing is to have the guy actually follow the spline. That should be cool. So let's private 3 project position. And might as well get the tangent as well, because we are going to need that. And we're going to want the curvature. Tangent equals spline pass. Get tangent param project curvature equals spline pass dot get curvature dot magnitude normalized. Okay, so we save those in update. I'm gonna put this guy here. Now, where we're going to be using those is in desired velocity. So nav agent has desired velocity. We're going to make this guy virtual. Desired direction as well. And we're going to need to override both of those, I think. Desired direction is never actually used, is it? I'm doing this because I don't think there's any point in having that be separate. Oh, so we don't need this arrived condition at all. Now, let's go ahead and override that. Now, I need to go to the bathroom again. I will be back pretty quick. All right. So I was going to implement desired velocity. So basically, when we're following the spline, there are going to be two components of our desired velocity. The first one is that we want to be traveling along the spline. So that's going to be velocity aligned with the spline's tangent. So let's see. Vector 3 tangent velocity equals proj tangent times one. I guess just proj tangent. This desired velocity thing is... How does this work? Yeah, so I guess it's just direction scaled down to 0. And then there's also the aligning velocity. And that is going to be proj position minus transform that position. Then we need to clamp the magnitude of this. Let's see. Private float alignment velocity scale equals maybe we just want distance of max alignment velocity distance. And let's say that this is 1.5 F. So it's just going to be this divided by max alignment velocity distance. And we need to do clamp magnitude. We need to clamp this to magnitude of 1. Now the aligning velocity controls how much tangent velocity we have, because we can only have 1 as our total velocity. So back in our shitty paint, we have our alignment velocity and our tangent velocity. Let's say that this is the max alignment velocity. And then, okay, so actually I need, I'm going to assume that this is length 1. So then this vector has to have a max length of 1. So if we know the length of this vector is 1, the length of this vector is a, that's our alignment velocity, then we can figure out the length of this vector. I guess all we have to do is we take 1 minus the square magnitude of this to get the square magnitude of this. Okay. So let's see. Float tangent square mag equals one point oh. I just got completely. I just went blank for a second. That was fun. Minus aligning velocity dot square magnitude tangent if so that's the max. Float tangent square mag equals tangent velocity dot square magnitude. Then we can say if tangent square mag is greater than tangent max square mag, tangent velocity times equals tangent max square mag over tangent square mag. I think we need to do the square root of this. Return tangent velocity plus aligning velocity. Then the only thing this won't handle is running up against the edge. So let's go back to here. I'm gonna need to borrow some of this stuff. We need acceleration. Oh, that's already exposed. So there's tangent velocity. Let's just say is greater than 0. We don't want next waypoint because we only want to consider the last waypoint. Has dot. Is there a current path dot end pause or end hit dot position? Is this guy exposed? Nah. I think I hurt my wrist a few minutes ago just sitting on the couch for a second. That sounds bad. I swear I was actually just sitting on the couch. I wasn't doing anything unwholesome. But yeah, I think measured velocity needs to be available. Where is measured velocity getting? I guess that's probably just an update, yeah. Blick. Vector 3 measured velocity. Get private set. Actually, why don't I just measured velocity is now public. That's already public. All right, let's try this. Doesn't seem to be working super well. Oh, we got a null ref. That could be part of the problem. That probably wasn't the problem. So it seems like we can eventually align to the spline, but it struggles. All right. One thing I want to do is get rid of all this stuff. It goes so fast. I mean, honestly, this isn't too bad at high speed. But he definitely does overshoot the end there a bit. Okay, I think I need to create a more realistic setup here, where instead of having all of these points, oops. I think I deleted the start point, didn't I? Yeah. I want to create a more realistic setup where he has obstacles to navigate. And yeah, actually delete, I'll pull this one back here. All right, we are at 2:50. I think I'm gonna hang it up at 3 hours, which will be in approximately 12 minutes, 11 minutes-ish. So let's just see how far we get before that point? Make that a loop so he won't stop after doing it once. I need to slow this down a lot. So yeah, so what I'm thinking is that on the curvy sections, I want the guy to go slower. And I have something that will tell me the curvature of the spline at a given point. So if I just plug in his projected position, actually I'm already doing that. So I already am saving that curvature value at the guy's projected position. So I think all I need to do is scale the desired forward vector by, or divide that by the curvature. And then the next thing will be to control the rotation, because I think that will be the thing that really sells this more natural movement along the spline, is rotating the guy a little bit differently. And I'm going to have this one, well, that'll be later on. I'll give this guy a pause so he'll have to like land there and then move on. All right, let's check out the curvature thing now, though. Let's put a header here. Header, this is going to be path following, whereas these ones are, no, sorry. Header path generation. So let's see. Oop. So min curvature scale, I guess. Min curvature scale equals 0.2f. Then we need to know at what curvature value float max curvature equals 0. I think 0.1 is a good value for max curvature. I remember I was playing around with this a little bit. We also need the curvature sampling distance. Let me see what values I was using actually. Hopefully this opens quick. don't know what it's doing here. Whatever, I'm just gonna, oh, okay. Right as I was gonna continue on, it loaded. So I was using 0.01 for the offset and 0.1 for the scale, okay. So then we'll do max curvature slowdown. It is 0.2f. So thinking based on the curvature, we're going to lerp our slowdown from, we're going to just lerp our speed from 1 to 0.2. All right. Then, so when we get the curvature, we can specify this thing just to give something else to tweak. Then velocity. Dehandle the acceleration estimate stuff. So here, let's actually private float get curvature value at float param, or I'll just do float input. No, we do it. Float param. So then we can change this to equals get curvature value at proj param. So float value equals that, then replace that with that. Now we need to scale this. So we just want to do, I think, an inverse lerp. Or maybe, I don't think an inverse lerp is, we can just do return math dot, not math, f dot clamp 01 value divided by max curvature. All right, then desired velocity, then we can just say tangent velocity times equals math of dot lerp from 1 to max curvature slowdown by proj curvature. Then I'm also going to draw the curvature by setting the color that we draw our line segments. Get curvature value at Then we'll just say green is straight, red is curvy. Green color dot red by curvature. Also, I can close this guy now. So for this first one, I think there is... Okay, there's some curvature at the beginning. Then it evens out. I think I want to avoid the base classes draw gizmos, actually. Don't think I want to call that. This is just drawing the current waypoints, and that's not... It might be better to do something else for that, or just draw the path, or the spline. Alright, so this curvature value is not quite right. It's too harsh. Let's try this. .46. Max curvature slowdown of 0.2 is probably too much too. Let's try 0.5. That seems better. And yeah, so we can just do 0.5 for both of those actually. Let's see how this looks without any gizmos. I think it would look better with some better rotation on him. But I am liking this a lot better than the jagged edge paths. I think this is pretty good. Alright, so 0.5 for both of them. Let's actually apply this to AI base. And I want to see how this runs in the real game. So we're going to go into level 1. and see how it works with the actual dudes. Which should have those properties I just set. Seems to be working pretty well. Just to confirm, I want to make sure that they are actually using the splines. Seems like, well, they're not on splines right now because it's just straight paths. What if I go up here? Now they've got splines. Let's see how they do following them. Yeah, pretty good. But they're struggling at the end, though. Alright, I think this is a good place to call it. And we're past the 3-hour mark, which is my goal today. So yeah, I think that's some good progress. The enemies are now using splines for navigation, and doing an okay job at it. Next time, I think the most urgent thing to do is the rotation. I think that'll make it look a whole lot better when they are just have a more sensical rotation. And then it looked like there might also be some bugs with the allies that I'm going to have to work out. Also, I might end up just doing this stuff this week. We'll see. Anyway, if anyone's still here, I hope to see you again soon. Thank you so much for watching, and I will hopefully be back next week. Goodbye.